Welcome to another Syvecs help video, and this help video is based on our new S7, S8 and S12 firmware 1.752. This is quite a big jump in firmware release, so hence is a point that I'm actually doing a help video on this, just to ensure that basically the users and dealers that are looking to upgrade to this firmware fully understand some of the changes that are present in that firmware and what effects it can have. So looking at the window that we have in front of us at the moment, SCAL, the version is 349, and that's really important. So the first step that we're going to go over is actually going to go to the website, download software, and before doing anything with the latest ECU firmwares, you need to make sure you are running the latest software suite. That's because there are new features that are in this firmware that basically require a new configuration software. So as it says in very clear capitals, latest suite is at the bottom of the post, and what we do is we put the latest version down the bottom here. So version 349 is the latest version, and you can just double click on this link and it will basically then download the latest S suite, which you can install, and then when you open SCAL next, you'll find that you're running the 349 version of firmware. So now you've got this version of firmware, what I'm actually going to do is run through some of these changes of the firmware updates from 7.11, which is our current version of S7 firmware, up to the 7.52. So first thing I'm going to do, I'm actually offline with just a basic normal calibration here, and I'm actually going to update this to 7.52. So what you need to do is actually first of all download the latest firmware executable, and that is found basically on the forum S7 slight delay latest firmware. And what you're going to find after this video is released is there is going to be a new version of firmware here called 7.52. You need to download that executable, that link, and then once you've downloaded that, the first thing you need to do is just run that executable. Doesn't have to be connected to an ECU, doesn't have to be the ECU online. You just run the executable on your laptop, and what that will do is that will install the 7.52 profile into your SPS folder on SCAL, and then that will allow you then, if you were to go into SCAL and go File New, when you go to S7, you'll see the 7.52 release of .sp there. And that's important because what you can then do is offline take your existing calibration that you've got, which for me is a 7.11, and then I can update that to 7.52 without having to actually even update the ECU yet. So I'm going to go ahead and do that. So I'm going to go cal, change software version, and you can do this as well for your existing calibration, 7.52, and then it will basically create the changes and the new maps in your firmware. Now this is a really important stage. Here you want to hit the tag button. Now you can go down all of these new maps to basically go over some of the new features have been added, and there is a lot. So we're going to actually just tag them and go through some of the really important ones. So as you can see, all the areas that now have been tagged with a yellow marker are basically illustrating that there has been a change to this section of the calibration. And what we're going to do is now go over some of these that I think will be really useful. There are a lot of changes that are probably not useful for every user, but there are some really important ones in here that would be great, especially for the next release that's coming, which has even more stuff related to torque control. So let's just run from the top. Calibration switches, you've basically got an override budget thing. You can now apply user budget, and this is used for if you want to allow an overboost button. You can override it and set a budgeting amount of time, how many times you allow the overboost to be present on how many laps, how long for. You have like credits. This is used for our LMP customers and motorsport. So this one generally not used so much for road car stuff. Run mode, fueling. Overrun fuel cut. So there's a real nice feature in here, the drive-by-wire limit. So overrun fuel cut, sometimes just having a fuel cut can be quite severe. So actually allowing you to have some mass air available when you're doing that, actually allowing you to actually close the throttle completely so that you literally jam it completely closed, actually sometimes there's a nicer feeling for an overrun with the fuel cut severity. So sometimes having a fuel cut severity and you've got the throttle cracked open quite a lot, there's still a fair bit of mass air there, and the transient from coming in and out of it could sometimes be felt. So sometimes having a drive-by-wire limit of say like 1% is really useful and helpful. Just be careful when you're doing this to keep an eye on your drive-by-wire one duty. What you don't want to do is target a limit that is less than the throttle position actually can go to, and then you wind up the integral of the drive-by-wire. So just keep an eye on that. Okay, wastegate control, really big feature changes in here. Under the map control now, there is the option to target pre-throttle pressure rather than the manifold pressure. So this has been a request of a few race teams, rally cars, and also some drag racers, where they want to have a pre-throttle map sensor and target the pressure before the boost control, to target the pressure before the actual throttle plate rather than after, allowing you to have some reserve pressure available. So that is that when you change that, basically all you're targeting then is basically referencing the pre-throttle pressure sensor rather than your manifold pressure. Under the wastegate position control, there's an option to do the same thing with the pre-throttle as well. Gear cut. In the closed loop gear cut main thing, there's a number of dog kicks allowed. What this basically, if you're when you're doing a sequential gear cut and change, if for example you've actually failed a shift and it's then done a dog-to-dog cut, which basically applies a full cut as well as kicking the solenoid for the output really hard, you can allow a certain amount before the closed loop main cut control fails and then defaults over to the main loop, open loop stuff. Gear blip, there's a nice feature in here, especially for cars that are running with a DCT transmission that basically are transiently a bit lazy in the terms of the way the throttle opens and the way that the torque rises. So what some of the original VAG cars do is they basically, during a downshift, they open the throttle plate but apply a torque reduction. And what that does is basically allow the mass air to accumulate in the intake manifold, and then once enough mass air is basically accumulated, they let go of the fuel cut so the engine rises rapidly in a blip scenario, so that basically, and the transition of the clutch change on a DCT, you actually get a nice crisp rising RPM. So in here you get the pre-blip. If you set up the pre-blip stuff, you can basically set how you want it to be based on fuel cut, ignition cut, and even retard now. Before it was just purely on fuel cut. Idle control, there is a real nice feature here. A lot of our base maps have this as CM maps, and people are starting to really max out CM maps, so it was quite important now to try and bring in some of those CM maps into the main code. So what you've got in here is now got the ability to have idle active time. So basically when you go into idle control, a timer will start, which is called idle active time, and you can set the breakpoints for this here. And basically what you can then do is you can have a duty kicker and a target kicker based on the amount of time that idle has been active. So for example, if I wanted to have it so that I blip the throttle and then I want to just kick the duty just for a few seconds to allow the engine to stabilize as it comes down from into idle, you can do that now, and then basically it will add 3% and then ramp that down as the idle time increases. And the same with the target, you want to make sure you do the target and the duty together. As we keep moving down, under the limiters now, and the rev limiter, you have now got in the drive-by-wire limit closing a engine speed derivative. Basically this is useful because if you're approaching the rev limiter extremely fast, you actually want to be able to have a different integral and minimum and maximum drive-by-wire target limits based on that. So basically, as you now have a variable called RPM average DT, which is the delta in which the rate of RPM is increasing. So as you're approaching a limiter hard, you can now change your limits and integral to suit. Really nice feature that. You've also got ability to disable the drive-by-wire rev limiter stuff during gear blip. For some of the DTC cars where they're using the gear blip to target a rev limiter, you don't always want the drive-by-wire function coming in, so you've got the ability to cancel that. And the same for during launch as well. Variable valve timing. Now this is a really important change that you need to really take care with. So basically the inlet base duty now has a function to be able to change versus the temperature and pressure. So in certain engines, we found that with different oil temperatures and pressures, the inlet base duty can change quite a lot. So what we've now got is the ability to be able to change what the breakpoints are based on in the inlet base duty. Normally the base duty in most of our base maps are normally just fixed values, but now you've got the ability to be able to change these. And if you go into the view customizing area, you can actually go into the variable vane and change what these breakpoints are based on. So if you want to put them back to RPM and say manifold pressure, you can, but you've got full control of that now. Now, one thing you'll have to remember with this is these maps, because they've been basically changed now to be a configurable item, the values will go to 0. Okay, this is the really important change. You need to make sure that you repopulate these tables with values that you had similar before. If this table was just say 40% all over before, then you can just put that back in and everything will work the same. Or you can take it to another step up and allow you to then program the base duty based on other factors now, like pressure and temperature. But for the inlet base duty and the exhaust base duty, this is really important. There is no easy way to be able to carry that over when you're changing the axis of the maps. So we have to default those maps back to 0. So when you're updating, make sure you set them back again. Otherwise your VBT most likely won't work. Output functions. Okay, so there's a nice feature in here. I'll come to that in 2 seconds. The aircon control. So you've now got the ability to have full PWM control. Some of the later engines have got aircon compressors that have got PWM control now. You can now set that up. These axes are adjustable, so you can come into the output functions aircon control and change what the y-axis is, as well as the disable source function. So that's a nice feature. And then you've also got the tacho output scale. So this is something that's been requested from a lot of users actually. So what this basically does is, some people have seen on our plug and play kits that have got CAN bus like the R35, RS3. When you change calibration switch position, the RPM counter shows the map that you're presently in, so you actually know visually what you've got. What we've now done for the older cars like the RB26, the Toyota Supra, and other kits that we still sell lots of, we've now added the ability to be able to indicate the cal select change on the tacho output. Now, generally in those base maps, they will be using the tacho output function in the pin assignments. So what you're going to need to do is actually move this over to the tacho scaled. So unassign it from here and then assign it here for which output you're using. And then from there, just change your pulses to rev match what it was before. And then in here, you can indicate the cal select changes and set RPM targets and indication times for each cal select position. So that's a really good feature that people have been requesting. Under data stream, the modified values, this has become really useful for some of the DTC cars. So basically on original ECUs, the relationship of the pedal position and TPS position, which is sent on the CAN bus, is not always the same and present compared to what the actual engine ECU is registering internally for its internal calibrations. So actually now having this conversion map, we allow people to be able to massage the PPS and TPS signals that are being sent out on the CAN bus to the TCMs to allow it to basically fool them into thinking that the PPS or TPS is open in a different position compared to where it actually is. This actually helps quite a lot in changing the driving characteristics of the car, allowing it to maybe move the auto shift points a bit earlier or later. So these maps are really useful. Okay, breakpoints and thresholds. This is something that's been requested by a load of people. The user configurable timers. So basically what the user configurable timers now do is they allow you to basically create a timer that is active from a certain threshold. So the default values in here are basically saying that it's greater than or equal to, and the threshold is RPM. So if I were to set this at 3000 RPM, then when the RPM was at 3000 or more, the first threshold and test would become true. Then for the same timer, you can set another threshold and test. So we're going to set the same thing again for greater than or equal to, and this one is based on TPS max. Now you can change these items under the view customizing breakpoints. You can change these to be whatever you want. So it's really, really useful, so you can basically create now these timers to become active based on any item. And then what you can then have is a time limit and a decay ratio of basically how fast it decays out after the thresholds have not been met. And when you've got those timers, you can then go gauge add user timer 1 and 2 here, so you can see these monitoring items. But the really important part is you can then link these into custom maps. So for example, if you wanted to create, I don't know, a timer that adjusted the wastegate position or wastegate duty after a certain amount of time it was active, then you can do that in here now. So you could just go wastegate final duty adder, and then you could say based on the user timer 1, and then based on, say, speed. These are just examples I'm just throwing out there. You can then come out of the view customizing area, go to configurable maps, set up your breakpoints and time, and then what you can have is based on the user timer and the speed you're doing, you can then adjust the wastegate final duty. There is so much you can do with this. There is also, if you in the Syvecs help page, you can search on custom maps, and there's even more stuff that you can do where you can make your own strategies three-dimensional by having raw composition values, and basically make layers upon layers of custom maps. It's really powerful. So watch that help video if you haven't already seen it. So let's keep going down. So the user timers are really useful. Sensors, lots of different changes in here. You can allow the acceleration sensor resets. Most of these are just small things, but the engine coolant pressure trip is a useful one. You can now basically set your over and under pressure based on the coolant temperature and the engine RPM. The reason before it was just based on coolant temperature. If you've got a mechanical water pump, sometimes you'll find and you'll see that your coolant pressure will rise with RPM. So being able to now adjust the over and under pressure is really useful function. Engine speed input. So this is basically a customizable frequency kind of input, where you can basically, instead of having to use, if you wanted to say look at the water methanol like a sensor, and you wanted to basically just code those signals coming in, then you can basically set up the pulses per rev and teeth per reading now, and then rename this item under the view customizing area to basically change this to a name that you want. Once you've changed that, you can then pull these into custom maps, etc., as you normally would do. Configurable maps, that's just new things. Obviously, in the pin assignments, any new stuff that's been added, new features, new maps, new items, they'll be set as undefined. So make sure you basically define those by just going not connected. Otherwise, the ECU will not come online when you try and program it with the changes. Now, there is another really important change in here that we need to discuss. So under the primary load select now, there is an option in here. As standard, it's normally manifold pressure and throttle position. What you've now got is you've got the ability to do normalized manifold pressure. So normalized manifold pressure is basically an accumulation of the manifold pressure and the air charge temp and density together to basically allow you to have one variable that takes into account those variables. Now, this is a really useful feature, especially for ignition maps and stuff like that, but you need to take great care, almost put it back on the dyno when changing these, because what you're going to find is you're going to hit sections of the map and areas where you'd not presently got to before. So we're going to add there will be some help notes on this in the latest F7 firmware section. At the bottom here, we'll add some notes on the normalized load that you should have a read of, but take great care of that. As well as all these other updates that I've listed here, there are a lot of new items that are now available in the CM map for Axis. So in here we've actually added all the cruise control variables that are in items in here now, the fuel pump duties, and a lot more things which will be listed on the firmware page in the list of changes. So that's something to take note of as well. Now, the last thing that I just want to go over with the latest 752, which is not actually present on the S7, it doesn't need it on the S7 because the H bridges are done in a different manner. On the S8 and S12, we basically added the ability to change the the logic of the drive-by-wire to match how we do it on the S7. So previously we would drive the outputs for the drive-by-wire and H-bridge channels at a very high frequency. What we've now done is we've now allowed the option to basically be able to run it at a different mode, which is a lot slower frequency. The reason this is quite important is on certain engines where the harmonics through the intake manifold, which are like aluminium and stuff like that, they can basically have a issue where a certain resonance through the intake and a very high frequency through the motor windings of the throttle can cause an instability in the motor control logic and windings. And what can happen then is the power through the actual motor starts to drop and you start to see the throttle closing. Manufacturers and dealers have and automotive shops have got around this a lot by basically applying dampeners, but we've actually gone a step further. On the S7 we didn't find it so much of a problem by allowing you to change the drive logic of the full bridge mode here. So you can actually now come into here and select this option to change the alternate internal full bridge mode. And what that does, there's some help notes here explaining basically what I've just said, but what that does is it drops the frequency to a much lower value to basically try and help in these circumstances. So if you have got an S8 or an S12 that you basically are experiencing this, you can try the alternate internal full bridge mode now, which will I'm sure help. Now, one little tease that is coming up, that a new firmware release is very imminent as well. I've been testing it for a long time. It's in this branch of the 759, which is an internal test branch, but we've now got the ability for monitoring the throttle mass airflow through the throttle bodies for each internal plenum. So you can now monitor your manifold pressure versus your pre-throttle pressure for each bank of the engine, put in your CD curve of the throttle, the diameter, and it will actually now calculate the internal mass air that is passing through that throttle per bank, which will then basically create a load of new variables over here on the right for basically being used in the torque control. It's also even got estimated horsepower and torque, which will be able to then link into your driven targets of wheel torque per gear, per speed, and a lot more. So there's some really great features coming. So little tease there, but otherwise the 752 is already a big step up.